Good day once again, grade 9s. I hope these videos are helping you to understand the chemistry a bit better and that you are able to do the activities if you went through the videos. So this will be the third video that I'm making, and if you haven't watched the first two, then I highly recommend that you watch them as they are vital in order to understand the work from here on going forward. In this video, we're going to look at chemical formulas and specifically how to write those formulas. So how do you write the compounds like H2O or CO2? How do you get to these numbers and how do you know how to write them correctly? So that's what we're going to be focusing on today. But first, let's look at the activity that you had to complete in the previous video. So in the first activity, you have to calculate the number of atoms in each of these formulas. So in the first formula, we have 2 NaCl. So 2 sodium chloride molecules. So firstly, we see that there's a 2 in front, meaning there's 2 molecules, and then the numbers in the compound, we see that there's 1 sodium molecule and 1 chlorine molecule. But remember, if it's 1, then we don't write the 1. So let's look at this calculation. So first, the sodium molecule, we say 2 times 1 because there's 2 molecules and there's 1 atom in each molecule. So there's 2 atoms overall. And then for chlorine, it's the same. So there's 2 molecules, 1 atom, 2 atoms overall. And then if we add them up, then we have a total of 4 atoms. Okay, let's look at the second one. So lead oxide. So we see that there's 3 molecules in total. There's 1 lead atom in each molecule and 2 oxygen atoms in each molecule. So the number of lead atoms is 3 times 1 and the number of oxygen atoms is 3 times 2, and if we add them up, then there's a total of 9 atoms. Okay, and for the last one, the numbers are getting a bit larger, so let's focus on this one. So we see here there's 5 iron oxide molecules. Each molecule has 2 iron atoms and 4 oxygen atoms. So let's first look at iron. Iron is 5 times the 2 atoms in each molecule, so 5 times 2 is equal to 10. And oxygen is also 5 for the 5 molecules, but this time 5 times 4, which is equal to 20. So the total number of atoms is 30. Okay, so if you couldn't get this right and you're still struggling with this, then I encourage you to look at the previous video, but I don't want to spend too much time on this, so I'm going to move on for now. Okay, then for the second activity and the third activity overall, you had to complete this table. So it was pretty straightforward, and we discussed all of these things in the previous video. So if you got some of this wrong, then again, go watch the previous video. And I'm definitely not going to go through every element here. So first you had to give the element name and the symbol, and then the group number and the period, and then these last 2 columns is really what we focused on in the previous video, the number of valent electrons and then the valency. So the valency is very important for today. So make sure that you got these right. Okay, so here's the first part of the table. And then here's the second part of the table. So again, make sure that you have all of these correct, but I'm not going to go through them. So let's move on. Okay, so let's just quickly look at what we want to achieve in today's video. So the main outcome of today's video is to be able to write chemical formulas. Okay, so at the end of this video, you should be able to say, yes, I can write a chemical formula. Doesn't matter what elements is asked. Okay, but at some point in this video, things are going to get a bit more tricky, and you're going to have to be able to work with variable valency and with polyatomic ions. Now, you would not know what these are at this point in time because we haven't done them yet, but remember at the end that you just check back here and make sure that you can identify variable valency and polyatomic ions, and you know them, you know how to use them, etc. Okay, let's jump in. Okay, so when we write compounds, it's important to know that each compound has a very specific way of being written. You can't just write it in however you want to. You can't just write any letters and any numbers. it fits together in a very specific way, so you have to use very specific letters and numbers that corresponds with a specific compound that you are working with. So if we look at an example that we've looked at a lot, water, then we know that water is H2O, which means it has 2 hydrogens and 1 oxygen atom. And in the previous video, we looked at how the molecule looks like, and we looked at why that is the case. And this is the molecule that we drew as a result. Now you can't just go and change that and add another hydrogen in here, because there's no place for it to go. It doesn't fit there. Okay, these two fit because there was an open spot over there. But there is no more open spots for electrons, so you can't add another hydrogen in there. So it is very important that you get this right. Now, you can go and draw an atom like this each time, or a molecule like this each time, but that is very tedious. So a very fast way of doing that is by working with the valency. And that's why in the previous video we really focused on valency and where does it come from and how does it work, because this makes chemical formulas a lot easier. So let's look at it at a simple kind of math equation that we can use to work out almost any chemical formula. So when you write compounds, you will be given 2 elements and the compound that it forms. So they might say something like element X plus element Y equals compound XY. Give the formula for this compound. So then you have to go figure out what are the numbers over here. In this case, we're just going to use these placeholders. So element X and Y doesn't really exist. Neither does compound XY. So we're going to use this as placeholders, and you can use this for any chemical formula. So the first thing you have to do is you have to go to your periodic table and you have to look up the valency for element X and for element Y. And then you would come back and you would see that the valency for X is, for instance, X plus A. So A is another placeholder. And then the valency for Y is Y minus B. One will always be positive and one will always be negative. Then all you do is you write those two next to each other, X plus A plus Y minus B, and then you write X and Y again, and you carry over the valency. So I'm going to show you now. So you write it as XBYA. So the valency from X is carried over to Y, and the valency from Y is carried over to X. Okay, and it is, the valency is written in the upper corner of the symbol, and then when you write the formula, then you write it as a subscript. So then you write it slightly below the symbol. So this works best if you look at it. So I know explaining it doesn't do it justice. So just remember this, how this looks like, and where the arrows go, where the numbers are supposed to be written. Okay, but this over here you can use for any compound that you have to write. Just a few things you have to keep in mind. Firstly, the plus and the minus falls away, so you don't write the plus and the minus here. Okay, they fall away, and you have to simplify the equation. So let's say if this was X plus 4 plus Y minus 2, then it would become X2 Y4, but then you can simplify that as X1 Y2. But don't worry too much about that. We're going to do a couple of examples where I show you how this works. Okay, but remember this, all of this, okay, because this is what you're going to be using to write all of the compounds. Okay, so if you can do this, if you understand this, then you are set. Okay, so let's look at a few examples. So in this first example, they say sodium is heated and reacts with chlorine to form table salt, or otherwise called sodium chloride. So when we do this, we have to go to our periodic table. So let's first go to our periodic table, and we see over here is sodium, and over here is chlorine. Okay, so sodium is in group 1, so it has a valency of +1. Chlorine is in group 7, so it has a valency of -1. Remember, you're not going to be given the valency, so you won't be getting this in a test. So you need to remember what valency is each group. So I recommend as soon as you get your test, you go to your periodic table and you write these in: +1, +2, +3, +-4, -3, -2, -1, 0. So you write them in and then the rest will be easy. So you identify them on the periodic table, you identify the valency, and then you write it down. So sodium has 1 valence electron, so it has a valency of +1. Chlorine has 7 valence electrons, so it has a valency of -1. So let's look at how we do this. So the chemical formula, we write those two next to each other, and then we take this and we cross it over, and we take this and we cross it over. Remember, there's no number there, but there's an imaginary 1 there. So then this becomes 1 and 1. So then it looks like this, Na1Cl1. But then remember, we don't write the 1, so then it just becomes NaCl. Okay, so this was a very straightforward example because we didn't have to do anything else. We just wrote the symbols next to each other, but it just shows you how the process works. Okay, but there's 2 more examples, so let's look at those. So then for the next 2 examples, we have water and carbon dioxide. So water we know is hydrogen and oxygen. Okay, so we go look at the periodic table and we see hydrogen and oxygen. And we see the valency for hydrogen is +1 and the valency for oxygen is -2. So we write that down. We say H plus O -2. Okay, and remember again, there's an imaginary 1. I'm going to keep putting the 1s in there just to help you, but you're not supposed to put them in there. This is just so you visually see what's happening. Then if we cross them over again, we take the 2 over and we take the 1 over. Okay, then we get to that familiar formula of H2O. Okay, then let's look at carbon dioxide. So that is carbon plus oxygen. So again, we go and we identify our elements. So carbon is over there, and that's plus or minus 4. Just erase these. So now we have C plus or minus 4 and O minus 2. But remember, the one has to be positive and one has to be negative. So in this case, since oxygen is negative, then carbon will be positive. So that will then be plus 4. So then we have C plus 4 plus O minus 2. And again, we take the 4 over to the oxygen and the 2 over to the carbon. And then we have C2O4. Now you might be thinking, oh, but this is not the carbon dioxide that I know. I know it to be CO2. That is because we still need to simplify this. So if it has a number that both sides can be divided by, then you do that. So in this case, 2 can be divided on both sides. So then 2 divided by 2 is 1, and 4 divided by 2 is 2. So then you simplify it to CO2. Okay, so that's 2 of the most common chemical formulas, and now you know how we get there. So you're going to get some homework on this, but before we do that, we have to make things a bit more complicated. So unfortunately, things can't be that simple. So there's a few things that we first have to go through that makes it a bit more complicated. But once again, like I said from the beginning, it seems complicated in the beginning, but as soon as you understand it, you actually realize that, oh, I must just follow these simple guidelines, and it's actually not that difficult. So let's look at what we call transition metals and variable valency. So transition metals are these block of elements here in the middle that we've conveniently skipped up till now. Okay, and you might have been thinking to yourself, but what if I get an element from this block? What do I do? Because there's no valency given for that. Well, the reason there's no valency is because it has variable valency, meaning its valency changes depending on what it binds with. So this might seem very daunting, and how do we work with that? Well, there's a lot of chemistry that goes into this, but for grade 9 level, it's once again actually quite simple. So let's quickly look at the different transition metals. So all of them are popping up on screen, and you need to know this table, but like you'll see with the examples that we're going to do, again, it's actually not that complicated. In fact, this might even make it a bit simpler. Just quickly, something to note is when we write the compound names, we have to include the variant that we use. So for example, iron can either be +2 or +3 if you look in the table. So when you write the name, you have to include which variable you are using, or which variant of iron you are using in this compound. And when that is the case, when you have to write the formula, then the answer is given to you. So this actually, like I said, doesn't make it more complicated. Actually, if you think about it, it makes it a bit simpler. But easiest way to explain this is to do examples. So let's look at a few examples. Okay, so write the chemical formula for copper oxide. So we have to go look for copper and we have to go look for oxygen. Now if we go look for copper, then we see it is over here and oxygen is over here. Now the valency for oxygen is -2, but we have no valency for copper. So we know that, oh, it's a variable valency, so it can either be +2, +1, we don't know which one. Luckily for us, the answer is given to us in the question. It says there, the valency for copper, we're using 2. So we know that the valency for copper in this case is +2. You don't even have to go look it up. So then we can simply just say copper +2 plus O -2, and we do the same that we did for in the previous examples. We take the two numbers over, crisscross, and then we simplify, and then we find that the formula for copper oxide is just CuO. Okay, let's look at another example for iron oxide. So we're not going to fall for that trick again. So now we don't even have to go look for iron. We know that iron is going to be +3. And oxygen, again, is -2. Okay, so if you write that out, iron plus oxygen is Fe +3 O -2. And then if we take the numbers over, then we see that it's Fe2O3. And that is the chemical formula for iron oxide. Okay, so like I said, seems complicated in the beginning, and then you see that, oh no, it's actually quite simple. But if you didn't understand, if I didn't explain sufficiently, then you're welcome to message me and I'll see maybe I can figure out a way to explain this a bit better. But I think it's quite simple at this point. But once again, we have to make it just a tiny bit more complicated. Okay, so this part is actually quite complicated, simply because there's a lot that you have to remember. The process that you use to get to the final answer is still the same, but in order to get these correct, you have to remember a lot of things. So what we are working with are called polyatomic ions. And what these are basically molecules that either lost or gained electrons, which made them positive or negative. Okay, so elements have a valency that is either positive or negative, but usually when compounds form, then those cancel out. But sometimes that is not the case. Sometimes these molecules lose or gain electrons through other chemical reactions, which makes them positive or negative. So now you have a molecule with free electrons. So simplest way is just to put them on the screen and then show you what I'm talking about. So we have two different categories, positive ions and negative ions. For positive ions, there's just the one called ammonium, which is NH4+. Okay, we'll get to these numbers in a second. Then for negative ions, we have all of these, which is -1, all of those, which is -2, and then phosphate, which is -3. Okay, so like I said, you have to study these and memorize these, and that's what makes this a bit more complicated than the other two sections we looked at. So what this basically means is you now have a molecule. So let's look at NH4, so ammonium. You now have a molecule which overall has a negative or positive charge. So in this case, a positive charge. But when you work with this, you basically look at everything inside of the bracket as one thing. So you can just replace NH4 with X or Y, and then just follow the same principle that you've been following in the previous sections. So let's quickly look at how this plays out with reworking the formula that we looked at earlier. So let's look at a generic example of our X's and our Y's again. So in this case, we have element X reacting with polyatomic ion YZ, and that's going to form a compound that looks something like this, XYZ, and we have to figure out exactly how this is going to look like. So we start off by going to our periodic table and we look for the valency of X, and we're going to find X has a valency of plus A. So again, A is just a placeholder for now. Then our polyatomic ion you're not going to find on the periodic table. This is why you have to study that previous slide. You have to know the names and the valencies of all of those polyatomic ions. So you're not going to find it on the periodic table, you just have to remember it. So you recall that YZ has a valency of minus B, and you write that in. Again, B is just a placeholder for now. And then I like to write it with brackets. So put the symbols in brackets and put the valency outside of the brackets. That way you can treat everything inside of the brackets and just as a single symbol. You don't change anything inside of the brackets, you just keep it as is. So you just, wherever the equation goes, everything inside of the bracket stays exactly the same. So let's say there was numbers here, so a 2 and a 3 in here, then those stay the same. You never change those numbers. Okay, but we'll look more at this when we do a couple of examples. So we have X plus A and YZ minus B. So then we do the same thing. We take the A over and we take the B over, and then we're going to get, sorry, let me just erase here, XB, YZ in brackets, A. Okay, so again, just if my words don't make sense, then take in the visual information that I'm showing you. Okay, the A goes over and the B goes over. And then just like in the previous examples, the positive and negative falls away and you have to simplify the equation. Okay, so I hope this makes sense, but again, easiest way to get better at doing this is to do a few examples. So let's look at a few. So for our first example, we have lithium sulfate. So that's just simply lithium and sulfate. So there's no complicated naming scheme here. So lithium is an element and sulfate is a polyatomic ion. So lithium we can get from the periodic table, but sulfate you have to know and you have to have studied, and you have to know what the formula is and what the valency is. So I know that you won't know that at this point, but when you do the examples, you must study them, and before tests or exams you must study them, because you are not going to be given them in tests or exams. But let's go through the example. So lithium is Li. We go look on the periodic table, we see that it has a valency of +1, and sulfate is SO4 minus 2. Okay, but then when we have this, then the hard part is over. The most difficult part here was remembering this. Okay, so I'm going to stress it again. Make sure that you study the polyatomic ions, because if you can remember them, then the hard part is over. Now all we need to do is put some brackets around the SO4, and then we can carry over the numbers. So then we carry over the 2, so it's Li2, and we carry over the 1 from the lithium, and we write it as such. But we know that we are not supposed to write that 1, so that 1 falls away. And here's the thing, if the 1 falls away, the brackets fall away as well. Okay, so that's something to keep in mind, but it's not the end of the world if you forget to remove the brackets. Really don't stress too much about this little detail. It's not the end of the world. But the actual formula will then look like this: Li2SO4. So the brackets are only important when there's any number 2 or higher outside of the brackets, because then that's going to interfere with any number that might be here. So if there weren't brackets here, then it would read Li2SO42, so, or SO42, which is incorrect. So that's why we have the brackets when the number outside of the bracket is any larger than 1. But if it's 1, then the brackets fall away. Okay, I'm talking too much. Let's look at the second example, ammonium phosphate. So now we have 2 polyatomic ions, ammonium and phosphate. So again, study them. And if you study them, then you would know that ammonium is NH4 plus and phosphate is PO4 minus 3. Again, we put them in brackets, make it a bit easier. And then we take it over. So the plus 1 goes over and it becomes 1 over here. The minus 3 goes over and it just becomes 3 over here. We keep them in brackets because we don't want this 3 over here to interfere with this 4 over there. Okay, but this bracket on the other side can fall away, so it becomes NH4 in brackets 3 and then PO4. So I really hope that it's getting through to you. It's very difficult being somewhere completely different geographically. So I hope this is making sense, and I hope I'm coming across clearly in this videos. Again, if you don't understand, feel free to message me on Google Classroom. I will try and respond to your queries. Okay, so then the only way you guys are going to get to grips with the work is by doing examples. More than any other work, this work requires you to practice, practice, practice. It's like math. You can understand the work theoretically, but if you don't know how to apply it, then it's useless. So usually in class we do a couple of lessons where we just go through examples. We don't do any new work. We just go through examples and we practice it. So now you guys have to do that at home and on your own time. So please, I reduce the number of activities so that it's not overwhelming. So a couple of activities that I do give, please take some time and do them. And if you're struggling with them, feel free to ask on Google Classroom. Me or any of the other teachers will try and assist you. Okay, so here's the first activity for this lesson, activity 4. Number 1, give the formula for lithium that bonds to chlorine. So this first 3, I just give you the names of the separate elements. You go look them up in the periodic table and you work it out. For the second one, I give you the chemical name. So first one, magnesium sulfide. So you have to go look that up. So the first one, for example, would be magnesium plus sulfur. So you go look at the valency and you do the rest. Okay, then the next activity, or rather a continuation of the activity, so numbers 3 and 4, give the formula for lithium phosphate. So in this case, we work with polyatomic ions. So I'm giving you a tip there. So all of these are polyatomic ions. So you go to that section of the notes or of this video and go look them up. And then for question 4, we work with transition metals. So you'll see here all of them: copper, phosphorus, copper again, lead and iron. These are transition metals, so you have to go look them up as well. But you'll see that a lot of them, there's some helpful information right in the name. Okay, that's it for this video. It's half an hour long, so I hope you guys stay till the end. But like I said, only way you're going to get this is if you practice. So practice and let me know if you have any questions. Good luck.